Countdown.
Tahniah! Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Assalamualaikum dan salam sejahtera. Hai semua para guru, ibu bapa yang dihormati dan para pelajar yang cikgu kasihi sekalian. Selamat datang ke Pusat Tuition Akademi YouTuber Ayu. Usaha sama e-didik Malaysia dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Untuk mendapatkan keberkatan kelas kita pada petang ini, mari kita sama-sama mulakan dengan membaca Ummul Kitab Al-Fatihah. Apa khabar para pelajar yang cikgu kasihi semua? Harap semuanya berada dalam keadaan baik dan bersedia untuk meneruskan kelas kita pada petang ini. Cikgu percaya pelajar-pelajar dah tak sabar nak mengikuti kelas kita kali ini. Cikgu perkenalkan diri dahulu. Nama cikgu, Cikgu Nikmawar Hanifah binti Nik Hassan, atau Cikgu Mawar Kimia dari Kuantan, Pahang. Selaku moderator pada petang ini. Hari ini kita ada kelas tuition Prayu Kimia. Untuk subjek Kimia. Pada petang ini kita bersiaran secara langsung dari channel Teacher Lau Chaiwi, ataupun Teacher Vivi Lau. Sesiapa yang belum subscribe Teacher Vivi Lau, silakan tekan butang subscribe sebagai tanda sokongan kepada Teacher Vivi Lau. Untuk makluman pelajar semua, nama penuh beliau ialah Lau Chaiwi dari SMK Tinggi Klang. Tajuk yang akan disampaikan oleh Teacher Vivi Lau pada hari ini ialah reaction Kinetic. Khas untuk pelajar kimia STPM semester 1 ataupun ulangan 1. Pelajar dan para penonton dialu-alukan untuk mempelajari topik berkenaan. Kelas ini berlangsung lebih kurang 1 jam. Dah biasa, semua dah tahu kan. Bersama cikgu di studio pada petang ini ialah kita ada Cikgu Syahnun di bawah sana yang mengajar kimia matrikulasi dari Kolej Matrikulasi Pulau Pinang sebagai control host dan beliau juga merupakan KP bagi tim kimia Ayu. Kita juga ada Cikgu Fatiah Mansor dari SMK Seri Serdang yang mengajar biologi STPM sebagai pemerhati. Sebelum kita teruskan kelas, kita suka cikgu ingatkan semua pelajar dan penonton yang ingin menghantar komen agar menggunakan bahasa yang sopan, gambar profil yang bersesuaian untuk tuntunan umum. Sila fokus pada isi pelajaran yang akan disampaikan dan hanya menggunakan ruangan chat untuk menjawab soalan atau kalau ada soalan nak diajukan kepada Teacher Vivi Lau. Pada akhir siaran ini, link sijil akan diberikan dan anda hanya ada 30 minit sahaja untuk mengisi maklumat. Pastikan menggunakan email e-didik sahaja. Cikgu percaya semua yang hadir kelas pada petang ini merupakan pelajar-pelajar yang cemerlang. Mari kita tunjukkan disiplin yang baik. Cikgu harap semua boleh memberikan sepenuh perhatian semasa kelas ini bersiaran. Tanpa membuang masa lagi, kita serahkan kelas kita kepada Teacher Vivi Lau. Dipersilakan Teacher Vivi Lau.
Thank you, Cikgu Mawar, our moderator today for the awesome intro. Thank you, Cikgu Fatia, as our observer today. And also, thank you, Cikgu Shannon, my KP, as our control host today. Hi, everyone. Good evening, students and teachers for attending the class today. Welcome to my channel. So today we are going to learn about reaction kinetics. Part 2, continue by the lesson conducted by Teacher Tang. Okay, so let me introduce myself first. So my name is Lau Chaiwi. I'm from Pusat Tingkatan 6 SMK Tinggi Klang. My teaching experience is 19 years, and my YouTube channel is Vivi Lau. Okay, so this is the our team YouTube playlist. You can go to this YouTube playlist for the videos of subjects. Beside chemistry, we have Maths T, Mathematics M, Biology, Physics, Accounts. Okay, so this is PU Mathematics team. So this is the P for Mathematics team. Teacher Im, Teacher Eileen, and Zebu Zana. Then Biology team is led by Teacher Faiza, and we have Zebu Fatia, our observer today. Zebu Nani. Then accounts we have Madam Fiji and Zebu Yati. And chemistry we have Zebu Shannon, our control host today. So he's our KP. Then we have Teacher Tang, Zebu Mawa, our moderator today. Okay, so this is a portal for Pusat Tuition IU. So you can visit this portal for the class timetable, online class timetable. Okay, so let's begin our lesson for today. So today we are going to learn about activation energy. So you will learn how to define activation energy and also to use the Boltzmann distribution curve to explain the distribution of molecular energy and explain qualitatively in terms of collision theory the effect of temperature on the rate of reactions, and also explain the relationship between the rate constants with the activation energy and temperature using Arrhenius equation. So first let's look at collision theory. In a chemical reaction, molecules or particles react together if they collide. Okay? So the molecules in the collision must have a certain minimum energy, activation energy. And the molecule also have to correlate oriented to each other. And if all these three is done, the effective collision can occur. Okay, so let's look at the next slide. Okay, so let's look at what is the correct orientations. Okay, so for the first one, okay, so when the molecules are in the correct orientation, effective collision will occur. So if the orientation is not correct, the molecules will bounce off each other and the collision is not effective. Okay, so what is activation energy? So activation energy is the minimum kinetic energy for reactants to have effective collision. So the keywords are minimum kinetic energy for reactants to have effective collision and to initiate the reaction. So the symbol for the activation energy is EA. Okay, so this activation energy is used to break the bonds in the reacting molecule. So the new bonds can be formed in the products. So the bond is breaking and form the new bonds. Okay, so the Maxwell-Boltzmann distribution of energy. In practice, only a very small fraction of covalent molecules have energy more than the activation energy. So this is shown on the Boltzmann distribution diagram. We also can simplify the name as Boltzmann distribution of energy. So the y-axis is a fraction of molecules, the x-axis is the energy. So you can see here under the curve, the area is representing the number of molecules. So only a very small amount of molecules have energy equal or more than the activation energy. So for the example, we see this reaction. Hydrogen reacts with hydrogen will form two more of hydrogen iodide. So for this reaction, the activation energy is about positive 170 kilojoule per mole. So when the hydrogen molecule collides with an iodine molecule, a reaction takes place if the molecule has energy more than the 170 kilojoule. When a reaction occurs, 170 kilojoule kinetic heat and other energy is absorbed and used to break the hydrogen and iodine bonds. So when the all bonds are broken, new hydrogen iodide bonds will be formed. Energy is given out when the new bonds are formed. The overall energy changes are summarized in the next slide. So you can see here, this graph is the energy profile or reaction profile. Okay, so the y-axis is the energy unit kilojoule per mole mass stated, and the x-axis you can write progress of reaction or reaction coordinate. Okay, so the molecules must overcome the energy barrier. So activation energy is the energy barrier that must be overcome so that the reactants can be changed into products. So the molecules overcome the energy barrier and reach a transition state. So here it will change, it will form temporary bonds, all bonds and new bonds. Okay, so all bonds still remain. Okay, so the activation energy is used to break the bonds. So it will form the products. Okay, so the products will go down. Okay, so the activator complex is the intermediate, okay, intermediate species. So where the old bond and new bonds are still between the atoms. Okay. So the activated complex is not stable. So very fast it will form the products. Okay, so we have to know two graphs for the two reactions, endothermic reaction and exothermic reaction. So as you know, endothermic reaction is a reaction that where the reactants absorb energy. Okay, so the reactants will have lower energy than the products. Okay, so the enthalpy change is a positive sign. Okay, so the reverse reaction activation energy will be lower than the forward reaction activation energy. Then for exothermic reaction, the reactants will release energy when forming the products, and the products will have lower energy than the reactants. So this is a difference between the exothermic and endothermic. Okay. Then the enthalpy change is negative sign. Okay. Okay, so the reverse reaction activation energy will be bigger than the forward reaction activation energy. So an exothermic reaction is more stable. Okay, so question number 1. So students, you can try out the questions and write your answers in the comments. Consider the energy profile diagram given for the reaction A plus B forms C plus D. Which one of these statement is correct? Okay, so A plus B form the C plus D. So the first answer, the activation energy for forward reactions is equal to X minus Y. Or the answer, the activation energy for the reverse reaction is given by X, or the enthalpy of the reaction is X minus Y, or the forward reaction is endothermic. So this is a very easy question. So students, please answer the question.
Okay, ni Teacher Vivi Lau, Gao Min Chai answer C.
Answer C. Okay, very good. Answer C, X minus Y. Okay, try again, students. Try again. Enthalpy of the reaction. Okay, X minus Y, is it correct? Okay, any other answer?
Okay, Bun Long Lim, answer D, donkey.
Donkey. Okay, very good. So the answer is donkey. Okay, so let's look at the answer. Okay, so you can see the products have higher energy level than the reactants. So this is a endothermic reaction. So enthalpy of reaction should be Y only. Okay, you can see here. So the formula of enthalpy of the reaction is to take the energy of the products minus the reactants. Okay, so it's energy of product is higher, so minus reactant you will get positive. So for endothermic reaction, the enthalpy change is the enthalpy of reaction. Enthalpy change is positive. So the forward reaction is endothermic. Okay. Then for answer A, activation energy for forward reaction. So forward reaction is here from the reactants form product is forward reaction. So it's equal to X. So activation energy for forward reaction is X. Then the activation energy for the reverse reaction is from here to here, products to reactants. So you have to take the X minus Y. So B answer should be X minus Y. Okay. Reverse reaction is from here, product go back, form back the reactants. Okay, any question? No question. Okay, so we move on to the.
So far they have no question.
Okay, thank
Tak
you.
ada lagi soalan.
Thank you. So we look at question 2. So question 2, you have to sketch a profile. So you can try out before I show the answer. You sketch on your paper first. So normally question will ask you to sketch an energy profile for the reaction. So the question must give you, depend on the question for this question will give you activation energy. And they must give you the enthalpy change. Okay. Then only you can sketch the energy profile. Okay. So you try to, I give you 1 minute, you try to draw first before I show you the answer. Okay, so I show the answer. So we must have the first mark, 3 marks here for this question. So first mark, you have to label the axis. Must have the units, okay? So the y-axis is energy, kilojoule per mole, then the x-axis is a reaction coordinate, or you can write progress of reaction. Then second mark, you have to label the reactants and the products. So label the BL2, copy from the question, and the products, okay? So reactant on the left-hand side, products on the right-hand side. Okay, then also label the activation energy because the question give you activation energy. The question also give you enthalpy change, so you must show in your graph. So label the activation energy. Remember to roll the activation energy here, okay? Means from the reactants until the transition state. Okay? So not here, okay? Not from here to here, must from the reactants. So the reactants must overcome the energy barrier. So from this side. And the enthalpy change is the difference between the products and the reactants. So it's this side, okay? So must show the sign, negative 23.0 kilojoule per mole for the enthalpy change. Okay. Must show the unit also, the reactants and products. Show also the units. Okay. If not, you cannot get the second marks. Okay. Then the third marks is the shape. So the exothermic reaction always the products lower energy level than the reactants. Okay. So do you draw the correct graph? Okay. Let's look at the second question, the third question. Okay, so this one also sets a graph, but just now it's a exothermic reaction. Now we look at the energy profile for the endothermic reaction. Also 3 marks. Okay, after you roll the graph, calculate the activation energy for the forward reverse reaction. Given the forward reaction activation energy is positive 40.2 kilojoule per mole. Okay, so the graph. So like just now, okay. Label the graph axis, 1 mark, second mark, label the reactants. Okay, then the shape must correct. So this time no need to show the activation energy because the question didn't ask for activation energy. You see, the question didn't give activation energy. The activation energy is given in the second part. But if you show also, they will not minus your mark. Okay. So the enthalpy change must show, okay, because it's given. So this is a endothermic reaction. So enthalpy change is between the product and reactants. The difference, so it's here, positive 14.6. And the third mass also the same correction. So endothermic reaction, the products must have higher energy level than the reactants. Okay, so for the second part, I think you can try to do now. So I give you time. You calculate the activation energy of the reverse reaction. Okay. Given the forward reaction is positive 40.2. Okay. So given this one, forward reaction activation energy, okay, is the positive 40.2. Positive 40.2. So you try to calculate now. The reverse reaction, where's the reverse reaction? So you have to calculate the activation energy for the reverse reaction. So, any answer from the students?
Okay, Ani Zahira answer positive 25.6.
23, 25.6. Okay. Okay, very good. Any more answer?
So far not yet, tak ada lagi.
Oh, one answer. Okay, very good. So, let's look at your answer. Positive 25.6, very good. So, this is a formula for the activation energy reverse reaction. So, EA reverse equal to the negative enthalpy change plus EA for the forward reactions. So you take negative, bracket because enthalpy change is positive, you must write positive. If you don't write the positive, then you cannot get the marks. Must always show the sign. So negative bracket positive 14.6 plus bracket positive 14.2. So your answer positive 25.6 kilojoule per mole. Okay. If you don't use the formula also can, you can look at the graph. So the reverse reaction is here. Okay, so the reverse reaction is here. Okay, so you want to find this value, so you must take the bigger one minus the smaller one. Take the positive 40.2 minus enthalpy change. Okay. So don't need to memorize formula. Okay.
Okay,
Okay,
Chong Sing Chua pun answer the correct one correct answer.
okay, very good. Okay, so. Okay, any more answer?
Okay, they have two only, Ani Zahira and Chong Sing Chua.
Okay, very good. So now we look at the effect of temperature on the rate of reactions. So there are other factors that affect the rate of reaction, but today we just focus on the temperature. Okay. So when the temperature of the reactants increase by 10 degrees Celsius, the rate of collision increases by about 2%, and the rate of reaction increases by about 100%. So you can see here, when the temperature increased 10 degrees Celsius, the rate only increased by 2%, but the rate of reaction increased by 100%. So this means that the increase in the rate of reaction cannot be due to an increase in the rate of collision only, as the increase in the rate of reaction is 50 times the increase in the rate of collision. Okay, so the explanation. An increase in the temperature increase the average kinetic energy of reacting molecules. Okay, so the molecules now can move faster. Okay, hence, at a higher temperature, the number of fraction of colliding molecules with energy more than the activation energy is increased. Okay, so the frequency of collision increases, hence the effective collision frequency also increases. That is why the reaction rate increases at the higher temperature. Okay, so effective collision frequency increases because of the average energy of the molecules increases.
Teacher Vivi lagi 2 minit kita rehat ya.
Okay, so
Okay.
I move on to the next time. Okay, so now we use a Boltzmann distribution of energy again to explain how the temperature affect the activation energy. Okay, so you can see here, T1 is a T1 is a lower temperature than T2. Okay, T2 is higher. So when the temperature increase, the number of molecules with number of fractional molecules with energy more or equal to the activation energy increases. Okay? So because of that, more effective correlation will occur and the rate of reaction increase. So more number of molecules have kinetic energy equal to or greater than activation energy at the higher temperature. So effective correlation increase and the rate of reaction increase. Okay, so we look at this question. Okay, accidentally show you the answer. So the graph show the Boltzmann distribution of energy. So you are required to draw the graph with the lower temperature. Okay. So when the temperature is lower,
Okay.
the graph will shift
Alright.
to the left.
Teacher Vivi, okay, sebelum kita terus kepada soalan nombor 4 ni, okay, kita berehat sebentar, okay?
Okay. Thank you.
Tuition
kita berehat
online percuma. Tuition online percuma. Layari www.academyyoutuber bagi mengikuti tuition online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuition online percuma, mestilah Akademi YouTuber.
Okay, dipersilakan Teacher Vivi Lau untuk sambung soalan nombor 4.
Okay, thank you, Cikgu Mama. So, welcome back, students. So, you can see here when the temperature decreases, lower temperature, the graph will shift to the left. Okay, so it's shift to the left and higher than the. Okay, but the number of molecules with energy more or equal to the activation energy normally at the tail will be lower, so it's smaller, okay, than the higher energy. So you just draw one graph beside it. Okay, so state and explain the changes, if any, on the area under the curve if the measurement is made at a lower temperature. So you can write your answer in the comments. So what are the changes? What are the changes you can see on the area under the curve if the measurement is made at the lower temperature? If any changes? Then you can write your answer at the chat box.
Okay, we have answer. Gao Min Chai said no change.
No change. Okay, very good. So the explain. So you try to explain, Min Chai, why there is no change. Any other answer?
So far belum lagi. Okay, Gao Min Chai give reason. Okay, because total number of molecule is constant.
Very good. Okay.
Question. Question or answer, I don't know. Total number of molecule is constant. Question mark.
Okay. Your answer is correct. Okay. So let's look at the answer. So the area under the curves remains unchanged. So this area is the total number of molecules in the sample, which stay the same. Okay. So your answer is correct and very good. Okay. Any other answer?
Okay, Chong Sing Chua. Okay, bagi jawapan panjang. Okay, at lower temperature, less molecule achieve the activation energy and therefore the reaction rate is lower.
Oh, okay. So his answer is at the okay. So but because the question mentioned area under the curve, more general. So the one is about the activation energy. So cannot get the marks. Okay. Because it must follow the question. The question mentioned the area under the curve. It does specify the activation energy. Okay, so question 4C. The kinetic theory suggests that gaseous molecules must collide in order to react. Explain with reference to the diagram. Okay, why the rate of reaction increases. Okay, so student, you can write your answer in the comments.
Okay, any answers? Student, okay, Gao Ming Chai said more molecules achieve activation energy.
Okay, this time only you use activation energy one, because the question asks about why the rate of reaction increases. Okay, so because the number of molecules with energy equal or more than the activation energy increases. Okay, so 1 mark for mention at the higher temperature, number or fraction of the molecules with energy at least equal to the activation energy increases. You also can write equal or more. Okay. Then second mark is you have to mention number of effective collision increases. You also can write effective collision frequency increases.
Okay, they have the answer from Chong Sing Chua. At higher temperature, more molecule achieve the activation energy and therefore the rate of reaction increases.
Oh yeah, so you can get 1 mark. So you have to mention this one, effective collision frequency increases to get the second mark. Okay, next we look at the effect of the temperature and the rate constant. Okay. So a change in the temperature affects the rate constant of reactions. So if you still remember, the rate constant is in the rate equation. Okay. So when the temperature is increased, K usually increases. Okay, so for this we have to know Arrhenius equation. Okay. So what is Arrhenius equation? So the Arrhenius equation predicts that the rate constant is related to the temperature by K equal to A multiplied by the natural exponent to negative EA divided by RT. So A stands for the Arrhenius constant, or we can say collision frequency factor. Then EA is the activation energy of the reaction. R is the gas constant, 8.3140 per mole per Kelvin. And T is the thermodynamic temperature in Kelvin. So each reaction, different reaction will have different Arrhenius constant and the activation energy. So you need to memorize the equation. Okay, so based on the Arrhenius equation, you can see what happened when the activation energy decrease and the temperature increase. Okay, so when the activational decrease, the natural exponent negative EA over RT increase. Okay, hence the rate constant increases. So the rate of reaction increase. When the temperature increase, this value increase also. So the rate constant also increase. Okay, so normally we have to convert the K by changing the K into long K. Long K, or you can use log K. Okay. But normally we memorize this one easier, okay, because this one has a number here. So normally we memorize a long K equal to long A minus EA over RT. Okay. So when the equation give different temperature, so you can either you substitute the value into the equation, then you minus the equation, or you can use this formula. Okay, ln K2 divided by K1 equal to EA over R multiplied by 1 over T1 minus by 1 over T2. So you memorize this formula, or if you forgot this one, you can just substitute the values into this formula, then you minus the two equations. Okay, so you substitute the value, okay, then take the equation 1 minus the equation 2, you will get this one. Okay, so now we try out this question. The activation energy for the reaction B2 form product is 120 kJ per mole at 298 Kelvin. The rate constant is 4.20 times 10 to the power negative 7 per second. What is the Arrhenius constant for this reaction? So which formula to use? So you can see here they give you EA, give you one temperature only, and give you the rate constant. Okay. So you can write your answer in the comments in the chat box. Okay, any answer, Cikgu Mara?
Okay, so far belum ada lagi. Okay, student, you can try to answer. Susah soalan ni.
So which formula to use? So I go back to the previous slide. Okay. So you are given activation energy and one temperature only. And the rate constant also given. So you need to find the A. So which one do you think? So any answer?
Belum lagi. Teacher Vivi Lau, belum lagi, tak ada lagi.
Oh, okay. Still calculating.
Maybe. I hope so.
So students, you can actually use the formula here only because here we have two temperature. The question just give one temperature. So you just take any use any formula here, these three formulas.
Okay, we have first answer. Ani
Okay.
Zahira said 4.55.
Okay. Any more answer?
Okay, student try.
Okay. So we look at the answer. So
Okay, Ani Asir, okay. 4.55 times 10 power of 14. Yeah, correct.
maybe you use
Point.
8.314.
Yeah.
So this one, the constant will give in the question. Okay. So if your question give you 8.314, then you use 8.314. The question give you 8.31, you just substitute. Okay. So your value is around this one. Okay, very good. Okay, so we look at next question. Okay, so this one is they give you two temperature. You can see here. So means you have to use that's how the second one, the second formula when you compare the experiment. Okay. Calculate the activation energy of the reaction in kilojoule per mole. Okay. So you have to use this one. Sorry, this one is a continuing question from the first question. Okay. So you have to use the 298. Use the same rate constant 4.20. Or maybe for it, okay. So you use this rate constant here and the two temperature here to calculate. So you use the second formula. So any answer from the students?
Not yet. Teacher Vivi Lau.
So use the formula 1K1 divided by K2. So this one is T1, this one T2, this one K1, this one K2.
Okay, student, you can just substitute the value into the formula, is it?
Do you still remember the formula? So, any answer from the students?
Okay, Anis Zahira again.
Okay.
Okay, Anis answer 216.0 kilojoule per mole.
216.0 kilojoule per mole. Okay. Any other answers?
Okay, so far belum.
Okay, so let's look at answer. The 216 kilojoule per mole, okay. So you just write three significant figures in there because the question they give you three. Okay. So you follow the smallest significant figures. Okay, very good. 216. Hanisa.
Anis Zahira, yeah, correct.
Okay. Any other answers?
So far belum.
Okay. So very good, eh? So now we look at the last question. Second last question. So sometimes the question will ask you to use a graph method. Okay. So graph method, you have to roll this graph. Long K against the 1 over T. You also can use the log 1, log 10, okay? So if you use this formula, you rearrange, you put the 1 over T in front. So y equal to mx plus c, right? For the straight graph, straight line graph. So the y axis is the long K. The x axis is the T, 1 over T. X axis is the 1 over T. Okay, so the gradient is negative EA over R. Okay, so you get this one. Gradient is negative EA over R. Okay, then the y-intercept is the long A. So using the graph harmonious plot, you can find the EA. Okay, and you can find the harmonious constant, okay, or collision frequency factor, collision frequency factor. Okay, so must label the unit. Okay. Unit of the x-axis. Okay, so we try out this question. But you just I think no graph will be right. So I just show you the answer. Okay, so at a certain temperature, ethanol decomposes according to the following equation. So ethanol form the methane and carbon monoxide. So you have to calculate the activation energy for the decomposition of ethanol based on the following data by using so the question mentioned graphical method. So you must use a graph. Okay. So they give a table temperature and the constant. So you have to make another table to get the marks. Okay, so you have to draw another table 1 over T because your x-axis is 1 over T and the 1K, so must have unit also the table. Okay, so normally three significant figures. Okay, okay, then you roll the graph. Okay, graph 1K against the 1 over T. Okay, so the gradient is negative EA over R. Okay, so this is a graph. Okay, the y-axis is the 1K, x-axis is 1 over T. So must have the unit. Okay, negative 1. And then you roll the gradient. So make sure your gradient is point is clear. Okay, don't take a point that you use the calculator calculate one. The point must readable one. Okay. Then you find the gradient. So it's negative 2.1 times 10 to the power of 4 Kelvin. Okay, the unit don't write also can. Okay, so the gas constant given is 8.341. Okay, so you bring this one over here, multiply, then you get 174.6 kilojoule per mole. Okay, I think can round off again 175 kilojoule per mole. Okay, because the table is all three significant figures. Okay. Last question. Question 8. The relationship between the rate constant of a reaction and temperature is given by the following expression. Explain with the aid of a suitable diagram why the rate of reaction doubles with every 10 degrees increase in the temperature. So we have 6 marks here. Okay, so what do you think which graph to use to explain this one? What diagram we use for explanation of the increasing in temperature and the rates? Okay, students, you can write your answer in the chat box.
Before that,
Yeah.
Cikgu Vivi Lau ada satu soalan.
Soalan,
Ani
okay.
Zahira asking, if the question asks for T, okay, big T, okay, the T must be in Kelvin or degree Celsius for final answer.
So that's how you remember the hardness equation must Kelvin. Okay, the temperature must be Kelvin because you can see this one define the terms. The temperature is a thermodynamic temperature is Kelvin, so you must use Kelvin. Okay. Okay, so then you try to figure out what diagram you use to explain this question. Before this, we have discussed. Any answer from the student?
Belum lagi.
Okay. So you see here, they give you temperature increase, then they ask about the rate. Any answer?
So far belum ada. Okay, but we have another 3 minutes left, ya, Teacher Vivi
Okay.
Lau, sebelum
So
tamat.
I show the answer. Okay. So I show you the answer. Okay. So that's how we always use this one. Right? So again, we use a Boltzmann distribution diagram. Okay. So this one you have to really remember. Okay. Boltzmann distribution again. Explain the temperature increase and the rate. Okay. So you can see here when temperature increases 10 degrees Celsius, kinetic energy of the gas particles increases. Okay. You also can write average energy of the particles. Okay. So number of particles move with energy, you can write equal or more, okay, or you can write not less than or at least the activation energy increases double. But you have to mention double, okay? Increases double. So number of effective collision increases. So this one you have to mention increases double. Okay. So the graph 1 mark, I just label the axis, then the curves must correct. Okay. So lower temperature is to the left, then higher temperature plus 10, mention plus 10 to the right. Okay. So with a higher cell, with more molecules with energy more than the EA. Okay. So 1 mark for the activation energy shaded area. Okay, so 3 marks here, so 6 marks. Okay. Okay, so that's all for my presentation today. Thank you very much.
Okey, terima kasih diucapkan kepada Teacher Vivi Lau di atas perkongsian ilmu yang sangat bermanfaat. Okey, sebagai ulang kaji ya, kerana pelajar-pelajar pun dah habis silibus, okey dah belajar reaction kinetik. Okey, Alhamdulillah dah selesai kelas kita pada petang ini. Okey, tahniah diucapkan kepada semua yang setia mengikuti kelas kita pada petang ini dari awal hingga ke saat ini. Okey, sebelum kita tamatkan sesi secara langsung hari ini, okey, mohon tutup ruangan chat ya dan klik butang subscribe yang masih merah. Okey, dan aktifkan ikon loceng supaya para pelajar tidak terlepas sesi kelas yang seterusnya. Okey, sekiranya anda suka dengan apa yang dipelajari hari ini, okey, sila klik like and share kepada rakan-rakan di media sosial anda, FB, Insta, okey, untuk sebarkan ilmu dan beroleh kebaikan melalui perkongsian tersebut. Okey, sila type done. Okey, di ruangan komen sebelum link sijil diberikan. Okey, link sijil dah ada di situ rasanya. Okey. Terima kasih kepada anda semua kerana kehebatan kamu menyertai kelas tuition percuma pada petang ini. Okey, link sijil boleh didapatkan di bahagian chat. Okey, link tersebut akan tamat dalam tempoh setengah jam sahaja selepas live ini. Okey, sila pastikan anda guna email e-didik sahaja. Okey, sekali lagi cikgu ucapkan terima kasih kepada Teacher Vivi Lau di atas kelas petang ini. Begitu juga dengan Cikgu Syahna dan Cikgu Fatia. Okey, jangan lupa juga untuk mendapatkan jadual tuition online terkini melalui portal www.academyyoutuber.com. Okey, serta dapatkan info-info terkini. Okey, bantu cikgu untuk sebarkan kelas tuition percuma ini kepada rakan-rakan dan guru-guru seluruh Malaysia. Okey, semoga kita akan mendapat manfaat daripada kelas-kelas yang dijalankan. Okey, ingat hashtag bermula percuma selamanya percuma. Okey, insya-Allah. Okey, terima kasih kepada semua. Okey, segala yang baik datang daripada Allah. Jika terdapat sebarang kekurangan dan kelemahan adalah daripada kami. Okey, kelas tuition online percuma berakhir sudah. Di lain siaran, kita berjumpa lagi. Okey, Assalamualaikum. Bye-bye semua.
Dibawakan kepada anda oleh Academy YouTuber.